Today we're going to be practicing drawing Lewis structures for covalent compounds. I'm going to get you started and do a few of them with you. So again, the way you're going to do this is pretty simple. For HCl, for example, you are going to draw out the elements involved. So I'm giving you the formulas here to make things a little bit easier. H has 1 valence electron, Cl has 7. Since they're covalent, we circle them. Then when we draw our Lewis dot diagram, the circled electrons become the line. The lone pairs don't get forgotten. And then we have to draw the polarity arrow to show which way is the positive end and which way is the negative end. And then the reason I'm going towards chlorine and not H is that chlorine has a higher electronegativity than H. And then the name of shape is linear diatomic. If we were to do H2 as a comparison, this would be H bonded to H. Here I'll put the 1 valence electron at the top. It doesn't really matter if there's a single one where it goes. Circle the electrons. H line H. I don't have any lone pairs because there aren't any. Same name of shape, so I'm not going to write it in. But just be aware, HCl gets the polarity arrow. H2 doesn't because this one is nonpolar and that one's polar. We'll do 3 more and then that's it. So for S2, remember with S2, they have 6 valence electrons each, so it's going to look like this. I'm going to rotate the way the way I put my dots on there, just because I know that I'm going to have to circle these electrons. So there's 1 bond, there's 2 bonds, so that's going to be very similar to O2. I'm not going to draw this out. Name of shape, still going to be linear diatomic because it's still 2 atoms and it's still a straight line. The next 2 I just want to really emphasize. S or H2S, since S has 6 valence electrons, just like oxygen, and this is something that you should really become familiar with. Since it has the same number of valence electrons, it is going to make very similar bond shapes, or the same amount of bonds. So, for example, H2O is going to be the same as H2S, which would be the same as H2SE. So know those once you realize those patterns, if you know H2O, then you also know H2S and H2SE. They're going to be the same because they all have 6 valence electrons. So when they bond to hydrogen, they're going to bond to 2 hydrogen, and they're going to end up being bent. I'm going to allow you to put in the polarity arrows. I'm intentionally leaving them off. You're going to have to look up the electronegativity yourself. Name of shape, bent, triatomic. And then for CO2, carbon always goes, I'm going to start with carbon in the middle because it makes the most bonds, and it's got 2 oxygens. So I'll start with 1, and it's going to make 2 bonds to 1. And then I start with the other one, and then I'll finish with the other one, and it's going to make 2 bonds to that one. And when it's cleaned up, it's going to be double bonds, and the double bonds are what make it linear. Now, the thing to keep in mind, again, same pattern emerges. CO2 is going to be the same shape as SiO2 because Si and C have the same number of valence electrons because they're in the same column, so therefore it's going to do the same thing. You could even do SiS2, and that would be the same as CO2 or CS2. So as long as you're using something with 4 valence and something with 2 valence, it's going to make 2 double bonds. And so once you know these patterns, again, it will make things much, much easier. Also, I'm not including the polarity arrows on this one and this one. You have to do those yourselves. So you're going to keep doing that. The second page is more of the same, so I'm not going to go over any of those. The third page, just be aware that when we get to the third page, these are all going to be tetrahedral in shape. And again, I'm just going to start you off with 2 of them. So what's happening is, for the first one, it's going to bond to 4 H's. Carbon always wants to make 4 bonds, and in this case it has 4 H's. You can draw the Lewis from that, so it's going to look like this. And then for the next one, you're basically going to do the exact same thing. It's still going to make 4 bonds, but one of them, it doesn't matter which one, It's going to be a chlorine. So I lost an H, I gained a chlorine. Here I lose another H, I gain another chlorine. Lose another H, gain another chlorine. Lose the final H, gain another chlorine. And then this one looks hard, but it's not. It's a carbon bonded to an H, a Cl, a Br, and an F. And the reason I can do that, again, I'm stressing this issue, is because Cl, Br, F, and I, they're all in the same family, so they're all going to make one, they all have 7 valence electrons, they're all going to make one bond, so they can all be swapped, meaning you could do CCl4, CF4, CBr4, CI4, it would all be the same thing, because they're halogens, they're group 17, they can be swapped out for one another. All right, last thing I'm going to go over is when we get to this page. So this is the very last part, and you've got some C2s and some C3s. The only thing I'm going to start with is when you do a C2, make sure that you always have to start like this. Because again, since we're drawing a molecule, we have to make everything interconnect. If it's not all connected, like if I have, all some C's and H's over here, and then I have a separate H to H bond off to the side, then that's not one molecule. In order to be one molecule, it all has to be connected. So this is 6 hydrogen, this is 4 hydrogen, 2 hydrogen, so you're losing 2 hydrogen each time. If you go into your notes, you're going to see that. And then when you get to 3, say, oh, I actually did that wrong. I went straight to 3. So it's going to look like this. And then you get the idea. This will be 6 hydrogen, and then here you'll lose 2 hydrogen, but you'll have to gain another bond between carbons, and then here you'll lose 2 more hydrogen, you gain another bond between carbons. And for this one, it's going to be 3 in a row, so you should get the idea. We link them all together, and that's how we start. And then you're going to have 6 hydrogen to play with, and if you have enough hydrogen, then you can make it all singles. If you don't have enough hydrogen, you may have to make a double bond somewhere, and then here you're going to lose 2 more hydrogen, so you should get the idea. There's no names for these shapes because once they get this large, we don't name the shape. It's too complicated. And that's it for this video.